Hello, amazing people, amazing students, and all lovers of chemistry out there. I'm here with another episode on this series of acids, salts, and bases. This is the second episode, and I trust it's been an interesting experience thus far. Today, we want to look at an interesting concept called the pH scale. What is it all about, and what does it represent in chemistry? Let's go into what we have for today. Now, first things first, it is important to understand that the pH scale is a tool in chemistry that is used to measure how acidic or how basic a solution is. Okay, so if a substance is basic or if that substance is acidic, a pH scale is that tool that we use to measure the extent of the basicity of a substance and the extent of the acidity of a substance, and it ranges from 0 all the way to 14. Now, if the pH level of a substance is between 0 and 6.9, we call it acidic. Now, you can see over here I have the picture of a pH scale showing the representations of the levels of a substance. Either it is acidic, neutral, or it is alkanilic or basic. Now, if it ranges from 0 to 6.9, we say that substance is acidic. If it is on 7 on the dot, we say that substance is neutral. And if it goes from 7.1 all the way to 14, we say that substance is basic or alkaline in nature. Okay, so you can either use the word basic or you can use the word alkaline. The two of them mean the same thing. Now, it is important to also note that the lower the number, the stronger the acid. The lower the number of the pH level of a substance, the stronger the acid. Now, over here you can see at the acidic level of the pH scale, you can see that if the number is dropping from 7 all the way to number 1, it shows that the lower the number goes, the stronger the level of the acidity of a substance. So that's how the pH scale works basically. And the higher the number, the stronger the base or the basicity of a substance. So if a substance is, let's say, number 1, we say that substance is a very strong acid. If the pH level of a substance is number 1, we say it's a very strong acid. And if the pH is, let's say, 13, then we say that substance is a very strong base. And if it is on number 7, we say that substance is neutral. And I have a lot of examples that I'm going to be showing out to you in this video, so I'd like you to stick around and let's get more into what we have for today. So now that we've talked about the acidity of a substance as well as the basicity of a substance, let's move on to the next concept we'd like to deal with. Now, we want to talk about identifying acids, bases, and neutral substances. Now, there are ways or different ways which you can identify if a substance is an acid, you can identify if a substance is a base, or you can identify if the substance is neutral. First of all, you can use something that we call the litmus paper. Now, this is one of the most common indicators that we have in chemistry, the litmus paper. Now, if you place blue litmus paper in a substance and that substance turns red, it is simply telling you that it is an acid. And if you place red litmus paper in a substance and it turns blue, it is simply telling you that it is a base. If there is no color change, then it is telling you that it is neutral. So that's how the litmus paper works. Now, over here, you can see it has been indicated that the litmus paper tells you if a substance is an acid or a base, but it does not tell you the exact pH level. It doesn't tell you if it is 1, if it is 2, if it is 3, all the way to 14. It just tells you this is an acid and this is a base. So a litmus paper is basically limited in the level to which it can tell you if a substance is an acid or if a substance is a base. The next indicator you can use to tell if a substance is an acid or a base is the universal indicator. Now, the universal indicator, over here I have a picture of what it looks like, is a solution, a special solution that has been made in such a way that when it is placed in a substance, it gives a color change that reflects the level of the acidity or the level of the basicity of a substance. Now, here is what I mean to say. If you look at this pH scale over here, you can see we do not just have numbers, we also have colors that have been spread across the numbers from number 1 down to number 14. Now, how the universal indicator works is that when you place it in a substance, it gives a color change. For instance, if you place the universal indicator in an acid and it gives the color change red, you can see the color red is between 1 and 3, which tells you that the pH of that substance will be between 0 to 3 and the color is red. So that's how the universal indicator works basically. It works by revealing a color change that tells you the range in which the pH level of a substance will be found. I hope I'm communicating this in this video, and if I am, please, I'd like you to do me a favor by subscribing to this YouTube channel, liking this video, and turning on the notification bell icon, so when more videos like this come out, you'd be the first to be notified. Now, the third indicator or tool that you can use to identify a substance, whether it's a base or an acid, is the pH meter. Now, this is the most accurate of them all. It is an electronic device that gives you the exact number. Now, here is what a pH meter looks like. So what you do is to take this electronic rod, we call it an electrode in chemistry. You take this electronic rod and you place it in the substance that you want to test. And then over here on the screen, the exact number of the pH value will be revealed. So that's how those three indicators work to show you if a substance is an acid or a base. So having talked about that, now here is a color guide that I've created for you to show the level of the pH of a substance and the colors that it will reveal. So let's get into it. So if the pH of a substance lies between 0 and 3, then the color that it will give off if you use a universal indicator is red. And you can see over here the red, or the color red, ranges between 1 all the way to somewhere around 3. And if that happens, we say that substance is a strong acid. If the pH value of a substance is between 4 and 6, 4 and 6 will start from somewhere here and end somewhere here. You can see the color is between orange and yellow, and that's what is indicated here. Now, when that happens, we say it is a weak acid. But when a substance has the pH value of 7 on the dot, 7 is at the middle point between 0 and 14, it will give off the color green. And when it gives off the color green using the universal indicator, we say that substance is neutral. And a very good example of a neutral substance is pure water. We're going to be seeing examples of all these substances as we proceed. Are there any more examples? Yes, there are. Let's proceed to check them out. If the pH level of a substance is between 8 and 11, that is between somewhere around this point all the way to this place, the color that it will give off if you use a universal indicator will be the color blue. And when it gives off that color, we say it is a weak base. And if its pH value is between the number 12 and the number 14, it gives off the color purple. And when it does, we say that substance is a strong base. So that's how the values and the pH colors of substances are spread all across the pH scale. So here are some examples that we want to talk about. If a substance is a battery acid, for example, the sulfuric acid that you have in your car batteries is a very strong and corrosive acid. It has an approximate pH value of 1, and that 1 is at the point of red, which tells you that it is a strong acid. The next example that we want to talk about is lemon juice. Lemon juice, I'm sure many of you must have had an encounter with lemon juice before. Lemon juice has an approximate pH value of 2 to 3. 2 to 3 ranges from this point to this point. And it is also an acid because you can see on the pH scale from 1 all the way to 6, you have acidic as the category to which that substance belongs. So after lemon juice, we have vinegar. Now, vinegar has the approximate pH value of number 3, and number 3 is somewhere around here, and it is also an acid, or it is acidic in nature. I hope you're following, and I hope you're understanding every bit of what is being talked about in this video. The next substance is soda, Pepsi, or Coca-Cola. It has the approximate pH value of number 3, and number 3 is also somewhere around here, and that makes it to also be an acid. So you can see acids are not just limited to substances that you can find in a chemical laboratory. They are also substances that we use and even consume in our day-to-day activities. Next example on our list is the example of water, or pure water. Pure water has an approximate pH value of the number 7, and number 7 means it is basically neutral, because you can see neutral here has the value of number 7, and on the pH scale, number 7 is at the center from 0 to 14. So pure water is neutral because it has the pH value of 7. Now, having said that, let's move to the next example that we have. We have milk. Now, milk is slightly acidic. That is why the acid that milk contains is called lactose, or lactic acid. That is why people who don't like milk say, I am lactose intolerant. You see, that word lactose is actually gotten from the word lactic acid. So milk has the approximate pH value of 6.5. 6.5 is somewhere around here, in between 6 and 7, and it is still in the acidic range, so it is slightly acidic. So milk is acidic, but the level of its acidity is not so high, so it can be tolerated by your body when you consume it. Next example on our list is baking soda. Okay, bakers use this a whole lot. Baking soda has the approximate pH value of 8 to 9. 8 to 9 stands somewhere around here to this place, and that makes it to be a weak base, because it is still very close to the number 7, and 7 is neutral, so it has slightly moved from neutral to a level of being a weak base. It has not yet progressed fully into the realms of strong bases. I hope I'm communicating effectively in this video to you. The next example that we're going to be considering is soap. Now, soap has the approximate pH value of 9 to 10. 9 to 10 ranges from around this point to around this point. That makes it to be a moderately strong base. That's for soap. And then the next example that we have is bleach. Bleach is way more stronger than soap. It has the approximate pH value of 12 to 13. 12 to 13 ranges from around here to around this point over here. 12 to 13 makes it to be a very, very strong base. That's bleach for you, a very, very strong base. If you notice, the smell, in fact, of bleach alone is very, very strong. So here is a solved example that we have for this lesson. A student tests a solution with a universal indicator and it turns yellow. What can you say about that solution? So on the pH scale, let's find out where the color yellow is. So the color yellow starts from around this point and it fades when you get to around this point where it turns to green. So that means if the color of a substance is yellow when you use a universal indicator, it means its pH value will be between 4 and 6. And when the pH value of a substance is between 4 and 6, that makes it to be a weak acid, because strong acids have their pH value to be between 1 and 3. So anything between 4 to 6 makes it to be a weak acid. So that's how you use your pH indicator and your universal indicator to determine if a substance is an acid or a base. Not just that, you can determine if it is a weak acid or a strong acid, or a weak base, or a strong base. So that being said, we've come to the end of today's video, where we've talked about the pH scale and how to use indicators to identify bases and acids. Please, once again, I'm asking to do me a favor by liking this video, subscribing to my YouTube channel, and turning on the notification bell icon, so when more stuff like this come out, you'd be the first to be notified. Right before I go, my name is David, and all we do here is to take the mystery out of chemistry so chemi can make history. See you in the next video.